Hi, this is Linda Norris, and this is the second bubble sort video. I just want to quickly go through um, some of the things I didn't get to show you in the last one. When we finished the last one, you could see that every time this loop ran here, um, it would put the highest number in order. You can see how it does that kind of right here. And I had told you that the bubble sort is called bubble because the highest number bubbles to the top. I have another bubble sort here, and what I've done was I put some extra print statements in there so that you can see what happens each time this for statement runs. So this for statement right here actually. So essentially when I run this, you can see down at the console here, in order to put, this is just a 1, 2, 3, 4, 5, 6, but the 6 is way down at the very bottom of the list when we start. And this for loop here will run through, and each time it goes around, it pushes the 6 up one more level. So the 6 bubbles to the top. And then once the 6 is in order, it goes through and it pushes the 5. You can see down here. The 5 is here, and it starts to flip with the 1, and then it flips with the 6, and then that's the next to top entry. Then you go through, it puts the 4 in order. You only need one flip on the 4 there. Then it puts the 3 in order, and then it puts the 2 in order. And at the very end, once everything is in order, my switch variable is equal to false, which causes me to stop the while loop. Now if I go up here and I kind of flip things around a bit, let's put everything in order. And run this program. Typically what would happen without the switched equals false is we could put this in 2 sets of for loops, but that would force all the comparisons to be made every single time. So I have a 6 element array here. That means I'd have every time you go around, it would compare each element to itself, and then would do that times the number of elements. So essentially you'd be using this if statement a lot for something that's already in order, which would be inefficient because every time you issue an if statement, it takes time, and when the computer takes time to run, the program takes time to run, it costs money. So essentially, when you write a program, you kind of want to cut down on that time if you can. So by using this little switched variable here that checks, and if everything's already in order, you can see that it only does one check and it sees it's in order. There were no swaps at all. I'm done and I'm out of there. So that's essentially how the bubble sort works. And if we go over to Wikipedia here for a minute, we can see that it says as far as efficiency, the performance is worst case and average, where n is the number, O to the n squared, where n is the number of items being sorted. And you can see that here's the worst case performance over here. The best case is when everything's already in order, as I just did. And here's the average. So when you're comparing sorts, bubble sort is only at best an average sort. So hopefully this kind of cleared some of the other things up for you, and we can go on and look at the selection sort next. Thanks, and we'll see you next time.